Automotive Electronics Test 6. We're going to, you should have, because everybody had a copy of it. If you don't have it, it's because you lost it. Go make sure you got one. I mean, don't say we ain't got it, because I put one in everybody's bin over there. You know what I mean? Walk around there and see if you got it. Meantime, I'm going to plow into it. Vehicles equipped with manual transmissions have a clutch safety switch. What's a clutch safety switch? Why do you need a clutch safety switch? Because if you don't have a clutch safety switch, if somebody starts it in gear, it'll run into somebody or run into another car, or run over somebody or run into a wall. So they do, don't they?
Yes.
You gotta mash the clutch so you can crank the vehicle. That's the one. There should be a 2-minute wait between cranking attempts. Now this is a rule that is true, but who abides by that?
Isn't it 30 seconds?
Yeah, well, 2-minute, 30 seconds. Most of the time people don't pay any attention to any of this. They just keep working. They just keep spinning the starter, isn't that right? You ever seen this before? Hey, just work the tar out of that thing, you know. You may have to buy a starter, but you know. A starter should draw less current once it is spinning. That's true too. Once it's spinning, to start the process, it's going to spike up. We can put a scope on it and show you that. The 2 windings in the solenoid are the pull in and hold in, and that's true too. Starter solenoid. A neutral safety switch will have continuity through it when the transmission is in drive or reverse.
That's false.
That is false, because you don't want the starter working when it's in drive or reverse. And neutral safety switches work a whole bunch of different ways too. I mean, there's all kinds of different ways. You need to if you're working on one and you suspect the neutral safety switch, you need to make sure you understand how it's wired up. Make sure you put your name on your test. We've got tests turned in. There's one hanging on a board up there right now that somebody didn't put their name on. I don't know who it was. The ring gear teeth of a flywheel are badly worn in various spots. Technician A says this could cause poor drive gear engagement. Technician B says this could be cause a lower than normal starter current draw. That's A only. Did you know that most of the time whenever a flywheel stops, it's going to stop in the same spot? When you switch off the car, it usually stops real close to the same place, or either in one of 2 places. Because there's one place where there's a little more resistance on most every engine. What should be done to the system when a 0.7 volt drop is observed between the battery positive terminal and the starter solenoid with the engine cranking? Now we were talking about voltage drop earlier, right? Okay. What should you do? Should you install a larger battery? Nothing, it's acceptable. Replace the cable or component between the voltmeter leads, or none of the above. That's going to be C. You're going to replace the cable or the component between the voltmeter leads. Incidentally, I was telling you that story about that farmer that had me looking at his tractor because he had a good battery and everything and a good starter, and it wouldn't start. And it had one of those molded battery terminals in those days. I mean, gosh, this was probably 1974. And I figured out that the power was not leaving the battery terminal, even going into the wire. And so I put the battery terminal on the plow and bang, 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 and beat it out and crank, and then it cranked the tractor, you know. But he was kind of smacked around back then. Let's see, all of the following could prevent a starter solenoid from engaging except A, an open in the neutral safety switch, B, a shorted clutch safety switch, B, C, a bent armature shaft, or D, an open ignition switch. A shorted clutch safety switch would do what? Hello, somebody talk to me. Huh? It would not prevent the operation of the starter at all. You know, it just fire right on up. A vehicle is being checked for no crank condition. A voltmeter placed across the contacts of the starter solenoid indicates 12 volts when ignition is turned to the start position. A distinct click noise is heard coming from the solenoid at the same time. Technician A says the starter motor may have an open armature or fuel current. Technician B says the starter solenoid needs to be replaced. That's B only. Now, I will tell you too, though, that in some cases, if you're hearing a click, you know, it wouldn't be a bad idea to go ahead and take the starter off and bench test it. Because sometimes the engine will have something keeping it from turning. The worst case scenario is that the engine's locked up. Seen that before. Another scenario would be the bearing on the air conditioner compressor that idler, you know, the pulley spins. If that bearing is locked up, you'd swear you had a bad starter or something. And you take the belt off if it fires up, you know, you got a good deal. Incidentally, you guys got a sheet on that where you're supposed to actually you know, turn the crankshaft and see how much, how hard it is to turn. The overrunning clutch protects the armature from doing what? Overrunning clutch is built into the starter drive. And I had a starter drive up here somewhere. I can show you guys on that. But you know that little round part that's right below the gear on a starter drive? How many of you guys ever worked on a lawnmower? Old Briggs and Stratton lawnmower. You've done it. You take this little, you know, that little cord that you pull, it starts it, and then you got it sitting down in there, and there's some little balls.
Oh, see, I've never worked on one of those ones. I've only had lawnmowers.
Yeah. Well, the long and the short of it is that little square that the pull, you know, the pull part of it is sitting on, it's got an overrunning clutch in it, but it's a bunch of little balls that whenever they're laying down there where they're supposed to be, it actually catches and makes it spin. But when the engine starts, those balls can just dance around in there, and it doesn't keep trying to spin that pulley, see? And that's the way it is. It's an overrunning one-way clutch, kind of like what you have in an automatic transmission. And when those things, how many of you have ever heard a starter go, you ever heard that? That's annoying, isn't it? You ever heard that? You've lived long enough to hear that. You know, when it's spin over, that's the starter drive, that overrunning clutch, typically. The overrunning clutch will actually have some deterioration in that will cause it to do that. And that's the aggravatingest thing in the world when you're trying to start a car and it goes, you know, it doesn't quite spin long enough to start, and you got to keep fooling with it. And eventually it'll get to where it just won't do anything. That's starter drive. Which the following is true of solenoids. They use the electromagnetic field of a coil to pull a plunger into the coil. They're generally used to engage a starter motor with the engine flywheel. They operate with a movable plunger and usually do a mechanical job. What do you think? That's all of the above.
What'd you say number 10 was?
Ma'am?
Number 10?
All right. You tell us what the answer was based on what I was saying. The overrunning clutch protects the armature from doing what? Electrical short circuits, starting the vehicle while it's in drive, spinning too slow or spinning too fast. What's going to happen if it's still engaged and the engine starts up? You ever heard that? Yeah, you have. Somebody's got the starter engaged, they don't let go of it, and it makes a little noise. Keeps it from spinning too fast. Okay, the overrunning clutch does what? Number 12?
D.
Huh?
D.
Separates starter motor from the flywheel, brings the starter motor into contact with the flywheel? No. Well,
C.
the overrunning clutch, you could say does all those things. But if I was taking an ASE test and I saw that, I would not like to put all of the above there because that's really not a very well written question. But all of the above is the correct answer. And so kudos to Curtis for that. So a starting safety switch is also called a what?
D.
Manual override switch.
No, come on. That's actually on some of your four-wheel drives. That's a little thing where you can push a button and start it without having a master clutch. C, a neutral start switch. Technician A says a full battery test series should be done before testing the starting system. If you know how to if you got voltage drop anywhere and you don't have a good strong battery, you're wasting your time checking the starting system. However, if you've had a weak battery, if you've had bad corrosion on that, and you've been working that starter too hard too long, you probably burnt the dadgum thing up anyway, you know. Now let me ask you this. My wife, we sold this car to my dad years ago. It only had 28,000 miles on it. We bought it new, and the starter was wore out. Why? Why would a starter be worn out at 28,000 miles? Because mile for mile, she had started it more than most people do. A traveling salesman that starts his car and drives it 500 miles a day, mile for mile, he's not starting it as much as somebody that has 28,000 miles in 8 years, right? So you're going to be starting it more for the miles you drive it. If you start it more, if you don't have many miles on the car, you're subject to put a starter on it because you've started it more. And how many starts does a starter have in it? I can't tell you the exact number, but it's limited. You're only going to be able to start that car so many times with that starter before you start having problems.
I didn't know that.
Yeah, well, think about it. How many times can a piston go up inside and down in a cylinder before it's not gonna do before it starts to give trouble where it can't go anywhere anymore? Of course, some other part of the engine probably fail first. Everything that you have is only gonna work so many times, and then it's gonna die. Starter.
Well, I mean, like the exact number, I didn't know.
Oh, yeah. Well, you don't know, but what you're hoping is it will be more than you need. You know what I mean? You're hoping that you'll need to start it 10,000 times and the starter will last 12,000 starts. That's what you're hoping. But most people don't think about that. But every starter has only got so many starts in it. Just like every computer's only got so many boots in it. You know what I mean? You can only boot it up so many times. Of course, like I say, you need to be start rich and all that kind of stuff. Was that kind of a deep thing that I put you to thinking about? I haven't totally lost which one we're on. Which one are we on? 14. Technician A says a full battery test series should be done before testing the system. That's true. Technician B says the internal condition of the engine has little effect on the operation of the starting system. That's A only because B is a yo-yo. If the internal condition of the engine has got to do with, slowing it down because things are dragging or whatever, you got issues with that. Here's an example. Some of the older vehicles, they had the higher tension piston rings on them. If somebody's been trying to start it a lot and they wash the cylinder walls down and the rings are dragging on the cylinder walls without oil, you'll hear it sitting there going, rah, 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 rah. It just won't sound good. And you squirt a bunch of oil in there where it's lubricated again, it'll spin faster. But one that's been running is just healthier and friendlier to being started anyway. Okay. Technician A says a neutral safety switch can apply a ground to the starter relay. That's true. Technician B says the internal connection of the engine has little effect on starting the system. Excuse me, I read two questions mixed up. Technician B says the neutral safety switch can also control the backup lights on a vehicle. Who's right about that?
C.
Come on, guys. How's the backup lights work? Hello?
There's a reverse switch. No, wait.
We could both.
The neutral safety switch is actually part of the backup light switch is part of the neutral safety switch. I shall now tell you about a stupid mistake that I made many long years ago, sometime in the 80s. One of those things that you do that you just weren't thinking clearly. And if you'd been thinking clearly, you would not have done this. There was a early 70s, like a 70 or 71 model Ford pickup truck that came in to the dealership. And they said, the backup lights don't work. Well, the backup lights, I knew, were operated by the neutral safety switch, right? And there was a connector back there that was leading down to the neutral safety switch. Neutral safety switch got a connector on about that long, and it goes up there, plugs into the harness. All right, so what are you going to do if you're going to check the backup lights? What you going to do? You're going to put it in, turn on the key and put it in reverse, right?
Yeah.
That ain't complicated, is it? So I turned on the key and I put it in reverse. I verified the concern. The lights were not on. Okay, so I said, usually if you're going to check a switch, you remember I showed you guys on the relay a while ago? I said, let's take the relay and let's bypass it from the common to the normally open and see if the load works. So I'm going to do this on the neutral safety switch. I've got the neutral safety switch disconnected. I've got the connector that plugs into the neutral safety switch. And I looked at that thing and I looked at those wires in there and I said, I ought to be able to jump this from power to the backup lights and then go back to the back of the truck and see if the backup lights are on. If they are, what does that mean? That means this neutral safety switch has gone south, because I know I've got power there. So I'm up here underneath the hood of this truck with my butt stuck up in the air, digging on these wires, and somehow, with it in reverse and the key on, I managed to find the one that went to the starter. There was another guy standing by as the truck cranked up and started backing up with me under the hood. and there's brand new cars sitting back there behind me. Anyway, he reached over and grabbed a coil wire and jerked it off of it. I mean, he was that quick. He was that quick. You know, he reached over and pulled it off because I couldn't get to anything. But that's one of those little moments when you get so comfortable. You know what I mean? And at the time, I hadn't been working there very long. But I mean, it was just one of those little, you know, you get so into the job, you're not thinking, wait a minute, if I happen to start the truck and I'm up in here, how am I going to stop it? Because nobody was sitting in the truck. Nobody was behind the wheel. If somebody had been sitting there with their foot on the brake, that'd be different. See what I mean? You get where I'm going with that? I mean, you see how easy it is to make a mistake that at the time it was just, you know, a stupid mistake. And, you know, and that's one of those boners, you know. All right, then, I'm not supposed to tell you about my mistakes, am I? Am I supposed to sort of act like I've never made one? That's what. Actually, everybody makes mistakes. Okay, let's see. Technician A says speeding up the armature will result in decreased amperage draw. Technician B says slowing down the starter armature will result in increased amperage draw. Let's see. Technician A says increasing the amount of current flowing through a conductor will increase the strength of the magnetic field. Technician B says coiling a wire around a soft iron core will increase the strength of his magnetic field. Who's correct about that? C, both those guys are correct. If you've got a wire, if I just got a wire that's a copper wire and I got wrapped round, and I put current in it and I let it flow through it, I'm creating a magnetic field. But if I put a piece of iron through the middle of that thing, it's going to magnify that. It's going to make it that much stronger. That's why these little relay coil has got a little iron core in it, right? Technician A says the commutator is a series of conducting segments located around one end of the armature, which would be like this, right here, these little strips right here, that's what that is. Okay. Technician B says the armature is a stationary component of the motor that consists of a conductor wound around a pole shoe. This is an armature. Does this armature stay still?
No.
No, it spins, okay? Which of the following represents the correct sequence of steps that may need to be performed when testing a starting system? Visual inspection, battery condition, voltage drop, starter draw. Is that the correct sequence? What about visual inspection, voltage drop, battery condition, starter draw? What about that? Here's another one, battery condition, visual inspection, starter draw, or voltage drop. These are the ones you really got to think about. Let's do this, visual inspection, battery condition, starter draw, and voltage drop. That's the ones, that's the order it needs to happen in. All right. What, you were listening? Okay. Technician A says the neutral safety switch can apply ground to the starter relay, which is true. Technician B says the neutral safety switch can operate the backup. I don't think I ever, you know, that's C, you know, both of those guys are right. All right. You guys good? Anybody got any questions or comments?